Good morning and hello. We're going to continue today with 3-2 with functions. A function is a relationship between input and output. In a function, there is exactly one output for each input. The relation shown is a function because each element in the domain is paired with exactly one element in the range. So what they mean with this is if you take a look at these arrows, the pairings are done by arrows. So on a mapping diagram is a function only when every part of the domain has one arrow and only one arrow coming out of it. So right here in a mapping diagram, we see that we have 4 numbers in our domain and one arrow coming out of each number to an element of the range. Now, if they're not giving you a mapping diagram or a relation table, we do have a graph to look at. Now, to graph, we want to use what is known as the vertical line test. The vertical line test is real straightforward. What you want to do is attempt to create a vertical line on this graph, and it only touches the graph at one point. If it is a function, it will only ever touch the graph at one point. So let's take a little paper clip here. Pretend this is our vertical line. No. But if we pass this paper clip over our function, it only ever overlays on one part of the arrow. So this one is a function. Our graph over here, though, not the case. If we were to draw a vertical line as we go through, we now see that it is touching this graph at 2 points. So if we do a vertical line here, we see that it crosses at 2 points. This tells us that this one x value has 2 y values. In comparison, if we drew a line here, it only has 1 point that it touches. Now, for a quick example, let's show a mapping diagram that is not a function. So we have our domain and range. Our domain is going to be 1, 2, 3, 4, 5. And our range will be 0, 2, 3, 5. Now let's draw some arrows. 1 goes to 0. 2 goes to 3. 3 goes to 2. So far, so good still. 4 goes to 5. This is still a function. 5 goes to 5. And 5 goes to 0. Now we have a problem. This 5 has 2 arrows coming off of it, so it is not a function. If we were to have a list of points, so let's say we had 0, 3. 4, 5. 6, 7. And 4, 8. Now, if we were given this list to ask if this was a function, what we would do is we're going to look at those x values, and I see 4 is paired with 5 here, and 4 is paired with 8 there. Because 4 appears twice, not a function. So ultimately, the thing we got to think about is something is a functions have no repeating x values. Moving along. Determine if this is a function. All right. I have 4 elements of the domain, 4 arrows going out, 1 arrow attached to each element. For each element of the domain, there is 1 element of the range, so this mapping is a function. 2. Our domain is 2, 6, 8, 2. Our range is 3, 5, 5, -3. Uh-oh. Now remember, we don't care about the range when we're determining functions. What we care about right now is this x's. I see 2 goes to both 3 and -3. So the element 2 in the domain is paired with both 3 and -3. Oh no! So this is not a function. List of points. 2, 5, 4, 7, 8, 11, and 4, 13. Uh-oh. The element 4 in the domain is paired with both 7 and 13 in the range. This is not a function. All right, we get to our first check. Take a second to pause, try your hand at it, then come on back and we'll get this figured out. All right, which of these relations is a function? Number 1, let's take a look. I have 4 elements in my domain, 1, 2, 3, 4, 4 arrows and 1 arrow per element. Function. 2. Let's see, my domain. Uh-oh, I see I got a 0 here and a 0 here. I have a repeating 0 and it's attached to 2 different numbers. So this one is not a function. 3. Let's see, we have -4, -2, 1, uh-oh, I see 2 -2s. And -2 is paired with both a 1 and a -7. So this one is not a function. So only 1 is a function. Moving right along. We are on example 2 on the next page. 5 schools are competing in the long jump portion of a track meet. The distance of the players with the best jump on each team are as followed. Team 1, 20.6, Team 2, 21.5, Team 3, 20.9, Team 4, 19.4, and Team 5, 20.2. Let's fill in the values. Determine the domain and range. All right, the domain is the list of numbers in our input, and that will be our team number. So 1, 2, 3, 4, 5. And the range is going to be 19.4, 20.2, 20.6, 20.9, and 21.5. And remember, for domain and range, this goes least to greatest. And no repeating values. Determine if this is a function. For each element of the domain, there is one element of the range. So this relation is a function. All right, our next check. Pause here for a second. Try your best. And then let's continue. Baylor recorded the height of 5 of our friends. The heights in inches are as follows: Hunter 62, Ling 66, Ella 65, Omar 66, and Alma 67. Find the domain and range of the relation. All right, so for this one, easiest way to think about it is if we were looking up data, would we plug in a height to find a name or plug in a name to find a height? Think about grade books. Do you look up kids in a grade book by their grade or by their name? So for this one, the domain is the names. This immediately gets rid of any option that has numbers in the domain. This tells us that our range is height in inches. So our correct answer is C. Is this relation a function? The answer is yes. Every one person has one height attached to them. Moving on. Example 3, equations as functions. Determine whether 6x plus 2y equals 14 is a function. For any value of x, it will pass the vertical line test. Ugh. There are no more than 1 point on the graph, so the graph of the equation is a function. What they're stating is, if you're not sure on an equation, you graph it and do the vertical line test. This vertical line represents individual x values being plugged in, and where it crosses is the solution, the y value. Since we can pass this across without it touching more than once, this is a function. All straight lines are functions unless it's a vertical line. So in general, if you're dealing with a straight line, just lines in general, because all lines are straight, it will be a function unless it is vertical, because if it is a vertical line, it fails the vertical line test. From here, we're going to example 4, finding the value of function. So this is function notation. We have the function of x is negative 2x plus 9. Find each value. So it now asks us f of 4. This is telling us to replace every instance of x with the number 4. So we wrote our function out, and instead of x, we wrote parentheses, and we plug in the value of 4. Negative 2 times 4 is negative 8. Negative 8 plus 9 is 1. 1 plus 3 is 4. So f of 4 plus 3 is 4. Notice how that the function has brackets around it. That's to make sure we know what we are working with. All right, next up, we have the function f of 5 minus the function of f of 1. All right, so first up, f of 5 minus f of 1. We replace those with the function equation in graphs, not graphs, in brackets. Plug in our values. We have the value 5 and the value 1. 5 times negative 2 is negative 10. Negative 2 times 1 is negative 2. Negative 10 plus 9 is negative 1. Negative 2 plus 9 is 7. Negative 1 plus negative 7, which is the same as negative 1 minus 7, is negative 8. To our check, pause it real quick, give yourselves a chance. All right, so we have f of negative 3, f of x equals negative 3x plus 2. Solve for f, the function of negative 4. All right, so we have negative 3, parenthesis, negative 4 plus 2. Negative 3 and negative 4 make positive 12 plus 2, which is 14. F of 5 plus 8, so we have negative 3 times 5 plus 2, and then plus 8 comes after. Negative 3 times 5 is 15, negative 15. So this becomes negative 15 plus 2 plus 8, which is the same as plus 10, so this gives us negative 5. Finally, we're going to subtract them. We have negative 3x, 3, plus 2, minus negative 3, oops, don't write those x's, we're putting in parentheses, 6 plus 2. Negative 3 times 3 is negative 9. Negative 9 plus 2 is negative 7. Minus. Negative 3 times 6 is negative 18. Negative 18 plus 2 is going to give us negative 16. Two minuses, add the opposite. Negative 7 plus 16 is positive 9. And that is it for our notes today. We are only going up through section 4. Thank you so much. Have a wonderful day.